This video will discuss question 23. In figure 2, assume L1 is L2 is L, C1 is C2 is C. To meet the Barkhausen criteria for oscillation, it is required that, and then 8 options are given for constraints on the transconductance and the resistances in the circuit. This is the circuit that we're going to discuss. Each stage has a transistor, an L component, C component and an R component, after which the stage is repeated. To investigate under which conditions the Barkhausen criteria are satisfied, I'm going to use the KCL method. And I'm going to do that with some small signal analysis. So first I'm going to draw the small signal equivalent network of this oscillator loop. And the important thing is that this V2 of the second stage will actually stretch into the beginning of the first one again, like this. So this will be V2, and that will then have impact on the currents that runs here. We call the potential at the top of the first stage V1, and we call the potential at the top of the second stage V2. Moreover, note that the transconductance values, so that's these two GMs, are identical, and that was given in the figure's caption as ideal transconductors with transconductant GM. They are models with the same transconductance. Let's set up the KCO equation for the first stage. We can impose two constraints now. Both the real part and the imaginary part should equate to 0. If we first do the imaginary part to 0, then we get the frequency of oscillation. So let's solve that first. And that'll give us a frequency of oscillation of 1 over LC. The second constraint is that the real part should be 0. And that'll give us the following. So if we think of the voltage with the name voltage 2 as an input voltage and the voltage called V1 as an output voltage, then the gain in this stage would be negative GM-R1. We can do the same thing for the second stage, and that will give us a completely analogous result. I'm going to omit the calculations here, but the result is that V2 over V1 is negative GM-R2. This first equation gives us the gain of the first stage, and the second equation gives us the gain of the second stage from input to output voltage. So if we multiply these two gains, that gives us our open loop gain that we can use for the Barkhausen criterion. So for the Barkhausen criterion to be true and oscillations to be sustained, the closed loop gain should be 1. So, in other words, the multiplication of these two factors of V1 over V2 and V2 over V1 should be 1. And we can now rewrite this to get GM squared is 1 over R1, R2. And that is the final answer.